Hello everyone. In this video we are going to find the determinant of a matrix by column or row expansion. So here we have a 3 by 3 matrix. We're going to find its determinant, and there's different ways to do it. So this is one way, which is a row expansion. So what I'm going to do is, I suppose, write down DETA for determinant A. And what does it equal? Okay, this is how I'm going to do this. I am going to expand across the first row. That's what the directions say. So what I do is I write down 2, 1, and 3. Those are the entries on the first row. Now what I do is I take that first 2 and I multiply it by a 2 by 2 matrix. And what is that 2 by 2 matrix? Well, it's the matrix A, which I'll write down here. And by the way, usually you don't quite show all this work. It's too much, but I want to explain this as I go. Okay, so here's the matrix A, but since I'm expanding across the first row and I'm at this first entry, which is 2, and what I do is I delete the row and column that contains that 2. And that leads to 2 times a 2 by 2 matrix. All right, so that's that first entry, or that's that first part. So I take 2, and then I multiply by the determinant of the matrix found by crossing out the row and column that have the 2, and that's this over here. So you don't usually show this step here. Just take the 2, put that there, then take the 2 by 2 matrix that's found by crossing out the row and column that contain that 2. And then I continue, but I come to the next piece, which is 1 here. Now for that one, I subtract. So there's a pattern that goes plus, minus, and then we're going to add again, plus. So we'll come more to that later. And again, what I do is I take the original matrix A, so I'll quickly write that down. And now I'm at this guy here, this 1. Okay, that's why there's a 1 outside there. And I cross out the row and column that has the 1. Okay, so over here, see I have this 1. I'm going to put down the 1 here, and then I'm going to cross out the row and column that has the 1. So, okay, so this is minus 1 times the 2 by 2 matrix, 1, 1, 2, 2. So again, I have this 1, that's right here, and then I cross out the row and column that has the 1, and I have the matrix that results from that. Then I just continue. And like I write down, or at least something like that in my head or somewhere, I have the original matrix. And now I'm at this 3. Okay, so I put the 3 there, and I cross out the row and the column that contains that 3. And so I'll get plus 3 times the 2 by 2 matrix, 1, negative 1, 2, 1. All right. Now I'm down, see I started off with a 3 by 3 matrix and I'm down to a 2 by 2 matrix. And by the way, if I started with a 4 by 4, I would do this method, really the same, and then I would get a sum of, or linear combination really, a sum of 3 by 3 matrices, and then I'd use this method to get down to 2 by 2. Let's do a little bit of an aside that was from another video, is that for a 2 by 2, if I have A, B, C, D, the way I find that determinant is I multiply across the main diagonal AD, and then I subtract across the other diagonal. Oh, I don't know. I forgot what the name of that is, but anyway, that doesn't really matter. BC. So I have AD minus BC. Okay. So therefore I have equals 2 negative 1 times 2 minus 1 times 1. Some people do this, a lot of this in their head, but anyway. 1 times 2 minus 2 times 1 plus 3. 1 times, sort of cramping my style here, getting this so in there. Okay. This is maybe where a lot of math mistakes come from, is just not having enough space and rushing or getting crowded. Okay, so we have those 3 determinants. It might have, this looks, see this line here, doesn't look messy. I think you just do it in your head. So you have 2, and you multiply negative 1 times 2 is negative 2, subtract 1 times 1. So isn't that negative 2 minus 1, which is negative 3? But I suppose we have to show that work. Okay, 2 times negative 3 minus, okay, 1 times all that. So anyway, this guy here is 2 minus 2, which is 0. There's another video where I talked about that if you have the 2 columns that are equal, then the determinant is 0. And that's just right there. The 2 columns are equal. The determinant is 0. All right, so then we come to the next one, which is 3. And I have 1 times 1 is 1 minus 2 times negative 1. So it's 1 plus negative 2. So that's 1 plus 2. So it's 1 minus negative 2. So that makes 1 plus 2. So that makes 3 times 3. So we get negative 6 plus 9. All of that equals 3. So that's, in some ways, maybe that's a lot of what you need to know in many cases to find a matrix. There's another fact here, which is that instead of expanding across the first row, you can expand across the second row, third row, or first column, second column. You can expand across those as well. There's a little trick here, though, is that when you do the expansion, you have to pay attention to this pattern where across the first row it goes plus, plus, minus, plus. And so with the expansion, it follows a checkerboard pattern. Are you more into chess? But anyway, follows a checkerboard pattern. And what I mean by that is it'll go plus, minus, plus. That's what we saw across the first row. Do you see? Plus, minus, plus. But then if you go along the second row, it's minus, plus, minus. And in the third row would be plus, minus, plus. And it follows a checkerboard. There's more you can learn about determinants, and it goes on. But anyway, that's one of the things we're going to assume is true. We're going to accept as a fact. So if I do this same matrix, it turns out that I could expand, instead of across the first row, I could expand across any row or column. I'm going to make that assertion without a proof. And so on this one, the first one, it's or this next problem, the second column was what it's asking for. So I'm going to expand across the second column, and when I do that, I'm going to use the pattern as shown above, or that checkerboard where it's minus, plus, minus. So I'm going to get the determinant of A, which I'll write as these vertical lines with A. Okay, it's going to be minus times a 2 by 2. That's not quite right here. Let's check this out better. You have this 1, so it's going to be minus 1 times a 2 by 2 matrix plus negative 1 times a 2 by 2 matrix minus 1 times a 2 by 2 matrix. Okay, what are those 2 by 2 matrices? So then I have this 1 right here. That's where this is from. So then I cross out the row and column that has that 1. Hold on, it's a little messy the way I did that. Let me try it again. I have this 1. That's here. Then I multiply by the matrix that's found by crossing out the 1. So that apparently gives 1, 1, 2, 2. And then I come to negative 1. That's how we get this. And then I cross out the row and column that has -1, and that gives what we see, 2, 3, 2, 2. And then here's -1. That's how we found that, or sorry, it's +1. There's +1. Put that there, and then I cross out the row and columns that have that, and that gives 2, 3, 1, 1. And so then I'll go ahead and define those 2x2 matrices. So this is sort of what you can do in your head. In this first one, we see that the two columns are the same, and I've talked about in a video before that if you have two columns the same, then you'll get a 0. That's your answer. So what we do again is we multiply across the main diagonal and subtract across the other way. So that gives -4 minus 6 minus, multiply 2 times 1 and subtract 1 times 3. I think you really can do that in your head, right? But maybe not, I don't know. Write out more work. The more, sometimes better. Oh man, I almost made a mistake. I was like, my big problem is I get too confident at the very end after I've done some of the hard work. Better get the same answer. It's a good check. See if I get the same answer. If I don't, then I'll redo the video. But I got the same thing. We got the same thing. It seems like, all right, it seems the determinant is 3. There's more ways to find the determinant. We can go across any row or column, and but there's other things we can do to find the determinant. So, okay, that finishes up this video. Take care, goodbye.